Welcome to Rges Algebra 2. This is lesson 23A, and we'll be discussing section 7.2. Now, 7.2 you could view as either a complicated idea or not complicated. It's not complicated in the sense that it's just a pattern. If you memorize the pattern, then you can do this problem. If you don't memorize a pattern, you can't. In other words, it's one of those things that would be very difficult for you to logically deduce. You must memorize the rules. Now, it is also difficult in the sense that the rules are complicated, or a little bit complicated. They take a little practice for you, and there's a lot of detail, so there's plenty of ways you can go wrong. So pay a lot of attention, that's the point, a lot of attention to this lesson. I would say, it's not severely difficult, but it's challenging. So here we go. We're going to be talking about the binomial theorem. Now, binomial, you know what a binomial is. Two terms. Okay. We know how to raise this to the first power, because anything raised to the first power is just itself. We know how to raise it to the zero power, because anything raised, curly. Okay, to the zero power is just 1. We know how to square it. Sorry, I'm sloppy here. I'll slow down here. To square it, to square the binomial, there's the binomial. And this is squaring it. And we know we do that by FOIL, or memorizing the pattern, which we've already taught. So that is the same as x plus y times x plus y. And that is the same as first terms, x times x. Outer terms, xy, inner terms, xy, combine them and you have 2xy. Last terms, y squared. Okay, so the binomial to the second power is that. Now we are going to learn a pattern for how to do x plus y to the third power, to the fourth power, to the fifth power, to the sixth power. And this is how it works. Our first term will be just the x to the third power. Our last term will be just the just the y to the third power. And we will have 2 more terms in between. The reason we'll have 2 more terms in between is you always know the number of terms will be the exponent plus 1. Okay, so the exponent's 3, so the number of terms will be 4. Because this is a plus, I will put a plus here and a plus here. Now, this will be, okay, this next term here will be 1 level down from the first term. So if the first term's x cubed, this will be x squared, and this will be with 1y. Okay. The next one will be 1 level down with the x's and 1 level up with the y's. X, y squared, and then this will also be a plus. So we're done with everything but our numerical coefficient, which I need in here, but I wrote too close together. So let me do that again. I'll have 4 terms. This will be plus 1 down with the x, 1 up with the y, plus, I forgot to leave room there also. Hang on. I want to leave room for the coefficient. Down with the x and up with the y, plus 1 down with the x from the previous term, up with the y, plus, and there is no numerical coefficient at the first one or the last one. So what would these numerical coefficients be? Well, you are going to go to the previous term. Let me change. So to find this numerical coefficient, I look to the previous term. I'm going to take the exponent times the numerical coefficient of always on the previous term, 3 times 1, divide by the order of the term. In other words, that's the first one. So I'll divide by 3. Divide by 1 because it's the first term. So I'll take 3 times 1, divide by 1, and that will give me the numerical coefficient in the second term. Now let's look at it again. To find this numerical coefficient, that's xy squared, but I don't know what the number is in front, I'll look at the previous term. I'll take the exponent, 2, times the numerical coefficient, 3, and divide by the order. In other words, this is my second term. And so the 2's will cancel out, and I'll get a 3 for this one also. So this is my answer. Let me do it again with the binomial to the fourth power. I will begin with the first term, x to the fourth. I'm going to have 5 terms in all. The first and the last terms do not have a numerical coefficient associated with them. Because this is plus, they'll all be pluses. Plus. To figure my numerical part, I'll look to the previous term. I will think exponent, so I'm looking over here. Exponent times numerical coefficient, what number's before the x, divided by the order, that's the first term, and I will get a 4. Now I will fill in my x's, 1 less x, so I'll have x to the third, 1y, and go to the next term with a plus. Now I need to figure out the next numerical coefficient. So to figure out this numerical coefficient, I will look to this term. The exponent is 3, the numerical coefficient is 4, and it's the second term. I could cancel, and I get 2 times 3 is 6. Then I'll fill in my x's and y's. 1 less x, that'll be x squared. 1 more y, that'll be y squared. A plus, because it's a plus up here in my binomial, and figure out the next coefficient. To figure out the next coefficient, I must always look to the previous term. My exponent of the x's is 2. My numerical coefficient is 6, and I'm the first, second, third term. 3 goes into 6. 2 times 2 times 2 is 4. Fill in my x's and y's. 1 less x, 1 more y. And if I notice on the next one, I will have no x's, so I'll have y to the fourth, and I'm finished. I should have 5 terms. 1, 2, 3, 4, 5. The first term should be x to the fourth, the last term should be y to the fourth, and that's your answer. Now I'd like you to do x plus y to the fifth. When you think you have it, I'm going to write it down here for you. So go ahead and put it on pause. When you think you have your answer, stop it. Now I will say you do have a symmetrical balance here. So this goes 1, 4, 6, 4, 1. The other one said 1, 3, 3, 1. Okay, so this one you're going to have 6 terms when you're finished. Go ahead and give it a try. So this should be your answer here. Now sometimes you will have instead x minus y to the fifth. And the only thing that changes is the first sign, okay, every other sign beginning with the first one you write. So this would be negative, this would be positive, this would be negative, this would be positive, this would be negative. Every other one would be negative, beginning with the first sign you write, which is actually referring to the second term. All right? So that is what it is. It's not that difficult if you practice it a little bit. Now it will get complicated, however, with the next idea. Let's go to this one. 3a minus b squared to the fifth power. Go ahead and put it on pause and write this out as though I had written x minus y to the fifth power. So figure this out and put the pattern in with x minus y's. It should be obvious, we just did it. Actually, let's go ahead and do it to the sixth power so that you can do something new. Okay, so just do it with x minus y to the sixth power and then come back to the tape. Now hopefully this is getting easier every time. It's really, as the more you do it, the more you recognize it's got patterns. By the time you get to the highest one, you don't have to calculate your numerical coefficient anymore because they're coming in pairs here. Right? And so hopefully it's getting easier and easier. Now, the problem is here, the trick in this one is that my original problem was not x minus y to the sixth power, but 3a minus b to the sixth power. Well, I can replace every y for a b, and that'll work, but I need to place a 3a for every x. So this really becomes 3a to the sixth power minus 6 times 3a to the fifth power b. See what I'm doing? I'm plugging in now 3a for every x and b for every y, plus 15 3a to the fourth power b squared minus 20 3a, unfortunately I'm running out of room, to the third power b to the third power. And I'm going to have to go to the next page and do this, repeat this one. So let me go ahead and do that. Now the last step then is to go ahead and calculate this out. Okay, 3 to the sixth power is, well, 3 squared is 9, so this would be 9 times 9 times 9. That's going to be 243, a to the sixth. Next term, take 3 to the fifth power. Well, remember, 3 squared is 9. That would be 9 times 9, which would be 81, times one more 3, and times 6. So that'd be all of that. This is a good thing to do a calculator with. Okay, 81 times 18, and your answer will be 405. So it's the number part that you want to be careful with, but go ahead and do it on a calculator. A to the fifth, b. The next one, I'll say 3 to the fourth. Okay, that's 81 times 15, and that's 270. A to the fourth, b squared. The next one, 3 to the third, that'd be 9 times 3, or 27 times the 20. Wait a minute, am I getting this right? 3 is 9 times 3 is 27. Yeah. Okay, I apologize for that. I was actually looking up to try to get my numbers rather than doing them all in my head, and I was looking at a problem that was different than this one. So this is 3 to the sixth, right? So 3 to the sixth, I'm going to take my calculator for each of these. Okay, so I've just kind of put some helps down here. So for the second term here, I'm going to have 3 to the 5th power, which is 243 times 6, which will be 1458. Then a to the 5th, b. The next one is 3 to the 4th power. That would be 81 times 15 is 1215. I wondered why they weren't coming out right before. Makes sense now. A to the 4th, b squared. Okay, so now I'm went ahead and put a chart down to help me. The first one is just the 729 is 3 to the 6th power. For this one, I pick up the 3 to the 5th, which is 243, and multiply it by 6. For the next one, I pick up 3 to the 4th, which is 81, multiplied by 15. The next one, I'm going to have 3 to the 3rd, which is 27, multiplied by 20. Will be 540. A cubed, b cubed. The next one I'll have 3 squared, which is 9 times 15, 135. A squared, that should be a b, b to the 4th. The next one, 6 times 3 is 18, a to the 5th, b, a, b to the 5th. And finally, b to the 6th. Okay, so this is my answer. So hopefully you saw how I did that by plugging in, and you have to still do all that multiplication. Okay, leaving your exponents. And so you're going to get good practice on this. I recognize that it's laborious, but it is a pattern that is used commonly. And so go ahead and take the time to learn it. And we don't have a whole lot of sections in this chapter that we're going to do. So go ahead and study this. Make sure that you can do it, duplicate it in class.